Okay, now we're going to watch Abby prepare a brain for slicing on a different machine, in this case a Vibratome. The procedures are very similar. In this case, she's going to block the brain. She's going to first make a slice to remove the cerebellum. Then she will make a slice along the longitudinal fissure in order to separate the two hemispheres. She'll then block the most anterior portions of the frontal lobe to leave a chunk of tissue that will allow her to best capture, in this case, the hippocampus. She's then going to take that brain and she's going to affix it to a block using super glue. Apply a small amount of super glue to the block, then apply the brain to that surface, allow it to dry for a few minutes to be ready to use. While that's drying, let's talk about the actual Vibratome itself. You would want to use a Vibratome whenever you want to slice a brain without freezing. Remember that we, in the previous demonstration, we froze brains in order to add additional rigidity to the structure to allow us to take thin, consistent slices. The Vibratome allows you to accomplish the same thing, but without freezing. So as a result, we can avoid any potential for freezing artifact or damage to the tissue. The Vibratome allows you to avoid freeze damage by changing the way the blade interacts with the tissue. On the sliding microtome, the blade slides from the dorsal surface to the ventral surface of the brain, and as a result, it can actually apply compression or pressure to the surface of the brain that actually compresses it. The Vibratome avoids that by making a lateral motion, so the blade is going to move side to side, and as a result, it produces less tearing and less compression of the tissue. Again, you would want to use this procedure if you are using poorly fixed material or if you are using completely unfixed brains. There are a number of knobs and dials on this machine which can be intimidating. On the front of the panel, we see two switches on the left. One controls, well, really they both control direction of the blade. The first one adjusts whether you're moving the blade forward or backward, and the bottom button allows you to pause that movement and then resume that movement from the point at which you left off. To the right of those two switches are two knobs. These two knobs control the speed of the blade movement as well as the amplitude of the blade movement. By speed, I mean the speed with which the blade moves across the surface of the brain. The scale runs from 0 to 10. We find that a speed of about 7 works best on fixed rat brains. So these are brains that have been exposed to formaldehyde. The amplitude knob refers to the range of motion that the blade makes from side to side. So again, the scale ranges from 0 to 10. We find that an amplitude of about 5 or 6 is optimal for slicing a lightly fixed piece of rat brain. You should also notice that on the top of the machine is a large dial. This large dial is used to both lower the platform upon which the brain rests. It's also used to adjust section thickness of the brain. You should always turn this knob in the clockwise direction when you are adjusting section thickness. It is gradated. I can't even say that word. What's the word I want? It is graduated, and that it lists thicknesses in terms of microns, anywhere from 0 to 100 microns in thickness. The machine is actually rated, or theoretically it's possible to take sections at all those different levels, but we find that the best slices are greater than 10 microns in thickness. In fact, we would recommend that you not take any sections thinner than 20 microns on this machine. The advantages to using this machine, again, are that it does not produce compression of the tissue, and it's often easier for the novice user to use and to get excellent slices from. You should notice that the reservoir is filled with saline buffer. All tissue slicing is going to be into this buffer, and we'll collect the tissue from this buffer and mount it later on slides. At this point, Abby is going to go ahead and put the brain into the well. She's going to lower the brain into a chuck, and she's going to tighten a screw in order to fix the block in place. Notice that the brain is under the surface of the buffer solution. She's also going to now mount the blade. The blade in this case is cheap, unlike the sliding microtome, which uses a very expensive manufactured blade. The Vibratome uses a standard razor blade. In this case, we're using a safety razor blade available from any hardware store. She mounts that blade, and then she needs to adjust the height of the blade relative to the brain. Actually, to be accurate, she's adjusting the height of the brain relative to the blade. The blade is fixed at a particular height, so it's only the brain that can move upward or down. To adjust the brain, she's probably going to lower the brain some, and she's going to do that by making a counterclockwise motion or counterclockwise movement of the dial on top. To advance the blade toward the brain, she's actually going to push the switch on the left side of the machine. You should notice that you can see some movement of the water. That movement of the water is due to the lateral movement of the blade. Like the sliding microtome, this allows you to take very even sections. So notice that the blade is going to move at the same speed across the entire surface of the brain. She's not getting a section here that indicates that, that the brain is actually positioned slightly below the blade. So she's going to reverse the blade, and she's going to move the thickness knob several hundred microns in the clockwise direction so that she can take her first slice. She'll take a few preparatory slices here before she actually gets a good viable one that we would use for data analysis. That was an excellent slice. Okay, so now Abby is going to reverse the blade, and then she's going to move the thickness knob 80 microns. So she's going to take an 80 micron thick section. So what happened then is as she turned that knob, the platform that holds the brain was advanced upward 80 microns. She then flipped the switch to advance the blade, which hopefully will get a nice section here. Although it almost never works after that. It'll be okay on the next one, next couple. We're going to let her advance a few through and just let it do it the 80 microns. Notice that as the blade retracts, the blade actually extends some distance behind the brain. You can minimize that distance by adjusting knobs on the left side of the machine. We find that for the most part, that's more effort than it's worth. This is a slow procedure, and it's not that slowness is not changed much by adjusting that distance. So again, she's going to take sections. She'll then capture those sections from the buffer. She'll place those sections into an ice cube tray that actually contains the same buffer, and she'll mount the sections later onto slides. You get the idea now of how to slice brains on this Vibratome. Abby's now going to demonstrate the cleanup procedure, which is simpler than we've seen before. The main task will be to remove the blade, discard it in an appropriate container, and then to remove the brain from its chuck. And the brain should be disposed of in an appropriate manner as well, and then the block should be cleaned off. The major task here is to remove the saline from the reservoir, And Abby's going to demonstrate how that is done. She's removing a plug that we have into the drain of this device. She's going to pull that plug, and the water is simply going to drain out of the machine into a beaker that we have down there. Once the reservoir is empty, wipe out any brain tissue that might still be floating or still be resident in the tray, and just dry it off, and you're done for the day.